Yeah, so between these five elements, aluminium is the one that has to lose 3 electrons, magnesium has to lose 2, and sodium has to lose 1, right? What that means is that aluminium, magnesium, and sodium, out of these three, aluminium is the least reactive. Magnesium is the one more reactive than that, and sodium is one more reactive than that. Okay, how do we compare sodium to potassium, and how do we compare magnesium to calcium? I've already given you a question for this to answer, so make sure that you answer that. But let me just tell you that potassium is going to be more reactive than sodium. And between these two, calcium is less reactive, potassium is more reactive. So we know calcium is more reactive, calcium is less reactive. Okay, that's how it goes. Potassium and calcium are like that, where calcium is less reactive, potassium is more reactive. And sodium is more reactive than magnesium, and magnesium is more reactive than aluminium. All right, now let's try to put this in order. Where does this fit into this row? So for that, remember that in group 1, regardless of कि भाई वो बड़ा है या छोटा है, उसने तो एक इलेक्ट्रॉन ही लूज करना है ना, तो ग्रुप 2 वाले से तो फिर भी वो ज्यादा रिएक्टिव होगा. So that what happens. Potassium बड़ा भी है, sodium छोटा है, so potassium is going to be more reactive. Sodium is the one next to it, क्योंकि जो मर्जी हो सोडियम ने करना तो एक ही लूज है ना, कंपेयर टू मैग्नीशियम कैल्शियम वो ज्यादा रिएक्टिव होगा. And then same for magnesium and calcium. Calcium is going to be more reactive because it has bigger atom, and magnesium is less reactive because it has a smaller atom, more attraction, more energy required to lose electrons, all of that. And then aluminium is less reactive because aluminium को तो 3 lose करने पड़ेंगे. So this is how the order works. This is how we say which is more reactive, which is less reactive, and this is called reactivity series. But remember one thing, that all of these are highly reactive compared to other metals in the group, in the periodic table, which is why whenever we want to extract them, we use a chemical technique called electrolysis, and we will have a few lessons on electrolysis. It's a very easy chemical technique, brilliant technique. So we use it to extract these metals. All right. Now, transition metals, on the other hand, are different from alkali metals. We have talked about alkali metals. We have talked about what they are good for. They're soft, they're explosive, they react with water, even at low temperatures, which means they're very reactive. And the reason they're very reactive is because of their sizes and the ability to lose just 1 electron. So we've talked about it. Now we're going to move on to transition metals. Transition metals are what we usually think of when we think of metals. They are high density, heavy things, high melting point, very strong. They withstand a lot of temperature, a lot of pressure, a lot of force that we place on them. We use them in construction material and all that because of that. They are shiny. They produce a ringing sound when we hit them. They are ductile, which means you can make wires from them. They are malleable, which means you can make sheets from them. You just have to keep on hammering it until you get a flat sheet. You can make laptops out of that, or even cars or rockets or whatever you want to make out of them, which is going to be quite durable if you make sure that it doesn't rust or corrode. So that's one thing that that's one word that you have to remember. When metals react with oxygen, we say that they are corroding. Okay, so corrosion is metals reacting with oxygen, and so metal plus oxygen is called corroding. So metal plus oxygen, that is corrosion. But when iron does it, this has a special name which is called rusting. So this is no different from corrosion. It's just that when iron does it, it's rusting. Now, if you remember, I talked about how some metals readily oxidize. So in other words, they corrode very fast. So that oxidation, what happens is that once they oxidize, sometimes that outer layer which has oxidized will fly away. But sometimes it will just stay there, leaving the inner electrons safe from the other one. So let's suppose I have this metal, and there's oxygen atoms coming out, and they are going to oxygen molecules attacking it and trying to react. So let's suppose it forms an oxide. An oxide forms on the outside, right? Now this oxide has formed on the outside, which means that now any new oxygen atom coming in will not be able to reach, let's suppose, an atom here, or an atom here, or an atom here. If there are atoms inside, they won't be able to reach them because there's an outer layer protecting them, right? So this is what happens when, let's suppose, sodium, you expose it to air, it corrodes right away. It's very reactive and forms a yellow layer on top. The moment you cut it out, you can see fresh silver metal, but you'll expose it to air, it will react right away. that layer stays there. Same for potassium, but potassium does it at a much faster rate than sodium. And there's a metal that does it, and we use that metal for this particular reason. Because you see, iron bhi ye karta hai, but the problem with iron is that once it starts to rust, it forms a powder or it becomes really brittle, which means it can break down and that powder goes away. So which means that the red layer that I have here, it will simply corrode away. और उससे होगा क्या? उससे होगा कि let's suppose मेरे पास ये ही थी और यहाँ पर ये corrode away कर गई है. So what happens is that now this side of the metal is going to be exposed to more oxygen atoms. So वो oxygen atoms यहाँ आएंगे and they will corrode the thing that is inside here. So the corrosion is much deeper now, and that goes on until all the metal is corroded. But compared to that, what aluminium does is that aluminium has this outer layer which is very, very strong. What that means is that this outer layer of aluminium oxide is non-porous. Okay, and it's silvery. What that means is that now any oxygen coming in will not be able to react with the metal particles inside, and not only that, this is not going to corrode away, this is not going to go away, which means now it's going to be pretty permanent feature of this aluminium piece, which is why we use aluminium all the time. We make windows from it, we make laptops from it, we make phones from it, things that we want to be durable, right? And the reason is that it has an outer layer of aluminum oxide. Every metal has an outer layer of oxide, but this one in particular, aluminum is very common. It's the most abundant metal on the earth. And then on top of that, because of this thing, it's very useful. Aluminum is also very light, which is why it is used to make aircraft parts. So that's again something that you have to remember. Aluminum is used to make aircraft parts because it is low density, has an aluminum oxide layer which is non-porous, so it can easily be used to make all those things. All right, so transition metals have one more property that is different from other metals, and that is that transition metals basically form colored compounds, and the reason for that is that they have variable valencies. Why do they have variable valencies? We study that in AS. It's just the second chapter, but again, we'll leave that out for AS next year. So how do we make sense of this? So here's the thing. If you get a metallic compound, you put it in water, it is colored. It tells me there is a transition metal present there. But if it is something else, some other ionic compound, and it's not colored, it is white. Remember, white is not a color in chemistry, right? So that means we say that this is non-transition metal. It is not transition metal. Now, what are not transition metals? So there's one in particular that you need to remember, which is not transition. Zinc. Not a transition metal. Why? Because zinc always forms zinc positive 2. That's it. Okay? So zinc is always positive 2. It doesn't form any other, which is why zinc is not transition metal. Okay, how do we treat transition metals differently? First of all, when we write them, if I have sodium, so sodium is, this is, I'm going to write it sodium. If I have sodium ion, I'm going to write it sodium ion. Okay, that's it. I know right away that this is sodium ion, it's going to lose 1 electron, positive 1 charge. But I won't do that with other things. For example, if I have iron, then iron, I'll call it iron atom. But this thing I won't call iron ion. I will say iron 2 ion. And this 2 in there is telling me that iron here has a charge of positive 2. So this is the charge. And whenever you name these ions, you have to name the charge. Okay? So these ions, you have to remember some of them for O levels or even IGCSE. So those are the ones I'm going to write them. So iron 2 positive. Make sure that you make notes here. I'm not writing it on a permanent noteboard. This is iron 3. Then we have silver, which is positive 1. We have to remember about copper, which is positive 1, and copper positive 2. We have to remember about chromium, which is positive 3. Okay, and that's good enough. The colors of their hydroxides. So again, these are hydroxide. Okay. So when they react with hydroxide, like sodium hydroxide or ammonium hydroxide, they form hydroxide. So iron 2 hydroxide will be green, iron 3 1 will be red or red brown. And remember one thing, do note it down somewhere, that if you expose green one, this iron 2 to the air, it will convert to this. So this converts when exposed. So if it are exposed to oxygen or something, it will just convert. So the green thing will start to turn red brown. Copper plus 1 is red, copper plus 2 is blue. Chromium is green. Again, this is chromium 3, not chromium metal, chromium 3. Okay. All right. Now, transition metals, because of their property to get multiple valencies, we use them whenever we want to use catalysts. So a catalyst is basically a substance that does three things. First of all, it reduces the activation energy of a reaction. Again, what is activation energy? It is the energy required to start a reaction. Whenever you start a reaction, you have to give it some energy. That energy is called activation energy. So catalysts lower the requirement to do that, which means that they reduce activation energy. That's one. Second, they do this by providing an alternative pathway. Remember, every reaction has a pathway. There's a method by which that reaction occurs. With transition metals, that method is different now. They're going to give us open new routes for the reaction to occur. So they do that by providing an alternative pathway. And the third thing that catalysts do is that they're chemically unchanged at the end of the reaction. So if I put iron 2, let's suppose, at the end of the reaction, I'm going to get iron 2 as well. And the reason transition metals are able to do that is because iron 2 can become iron 3 and iron 3 can become iron 2 back. That is not going to happen with sodium ion, because sodium ion, once it's ion, it's going to be quite hard to convert it back to atom. There's no other ion it can become readily. But with transition metals, that's very much possible. Which is why we use transition metals. Their variable valency is reason for two things. One is it gives them different colors, and two is allows them to become catalysts. So what catalysts are we talking about here? There are four catalysts or four reactions in which we have these catalysts. So I'm going to give a list of those reactions. So I'm going to share the other screen now. Okay. So the catalysts that we have to talk about. First of all, we have platinum. We can also have, I think, rhodium. I don't know how what the spelling. I think RH. Leave it out. It's rhodium platinum basically. Okay. So platinum is a good one. We have nickel. We have V2O5, which is not a metal but a compound actually. But that's okay because again, we can use these compounds to get different properties out of them. Okay. So that is V2O5, and lastly we have iron. These four catalysts, you need to remember them. Okay, how does it work? Platinum is used in catalytic converters. Catalytic converters basically make sure that only greenhouse gases do not leave car exhaust, especially those that are responsible for acid rain as well as greenhouse effect. So they're used in cars. With these, you have to remember that lead damages the converter or the catalyst. We say that lead poisons the catalyst. Okay. So if somebody's using car that has petrol which has lead in it, that car is going to damage the catalytic converter that it has. Okay. And that is one reason that if you go to next time you go to a fuel station, make sure that you note that they would have written unleaded petrol. Unleaded petrol means that they haven't used any lead in that. Okay. So where do we use them? So nickel is used in hydrogenation. And what do they make from them? So basically they convert vegetable oil to margarine. So nickel is used to do that. V2O5 is used in contact process. And in contact process, what it does is it converts SO2 to SO3. I'm not writing the chemical equation, this is just the process that happens. And iron is used in Haber process or Haber process. And what they do is they use nitrogen and hydrogen to make ammonia. This is a very useful, very important reaction. And we're going to use this equation multiple times. So these four catalysts, you have to remember them, okay? It's not that only these four are used or that no other are used. There are many other catalysts that come from transition metals, but these are the four that you need to remember. Okay, so that's transition metals. You need to remember their colors. You need to remember their valencies. You need to remember their processes. Okay. अब आ जाती है बात के other compounds. For example, KMNO4. Now, this is not a catalyst, but KMNO4 is a compound of manganese that is used as oxidizing agent. And the reason we do that is because it goes purple to colorless when it reacts. Okay. So when it goes purple to colorless, we can use that idea and find out that, okay, a redox reaction or an oxidizing reaction has occurred. Okay. Other things you need to remember about these metals. The first one is that copper is less active than hydrogen ion. Okay. So hydrogen ion is above copper ion, silver ion, gold ion, which means that copper, these all cannot react with acid, which are dilute. And copper only reacts with concentrated acid. Just remember that. With weak or dilute acids, these things will not be able to react, which is why gold is such a precious metal. One of the reasons that even if you put it in acid, it's possible that with weak or dilute acid, it will stay intact. But there are acids that we have made that will react with it. They're really, really strong. For example, in World War II, when Germans came to, I think it was Sweden that they invaded. So there was a lab in which there were a couple of Nobel Prize winners who were working, and the Nobel Prize medal is basically made from precious metals like gold. So they were using gold and all these precious metals to fund their war. So people didn't want to do that. So what they did was they put the Nobel medal that they had, the Nobel Prize medal that they had, and they put that in a very strong acid. So the acid dissolved them. By the time the army came, it was dissolved. Now, after the war, they went back to the lab and they actually extracted it from there. And the Nobel Committee or the Nobel Academy, whatever it is, they made a new metal for them and they gave them back to them. So interesting story about gold metals and World War. Anyways. So these are some facts that you have to remember about it. So zinc is not a transition metal, that you have to remember. And you have to remember the charges, you have to remember the usage, all of that. Now, there are some other metals for which you need to remember some things. For example, about calcium, the lime family that you have. So there is calcium carbonate, there is calcium oxide, there is calcium hydroxide solid, and there is calcium hydroxide aqueous. So you have to remember all four of them and you have to remember their names. All right. So what is this thing called? Calcium carbonate. What is it called in common language?
Oh, limestone.
Marble.
Limestone. Yes, very good. So this one's limestone. Where is it used?
For buildings.
So it is used in marble buildings. Similarly, school की grounds नहीं होती उनमें they have these white powder that they use to make these lines and all that, volleyball courts वगैरह बनाने में या football.
Sir,
Yes.
sir, it is also used to take out impurities from iron ore.
Excellent, excellent. So this is used to take out impurities. So to purify iron ore or many different ores, basically. Yeah. So I was saying that This is basically used there as well. This is the thing that we use to whitewash buildings, because this is the white thing in there that gives them the white color, and it's really cheap. इसको उर्दू में चूना कहते हैं. Okay. This thing, what is it called?
Quicklime.
Quicklime. Very good. What about this? Slaked lime. Any idea where we use it? We use it to fix soil pH. But you see, if soil is acidic, it won't allow many crops to grow healthy. So what we do is we add this slaked lime in there, and that way it can react with the acidic part in that and neutralize the soil. Why don't we use it dissolved in water? Because if it is dissolved in water, it will absorb into the soil, and that way it will just remain. The soil will then become basic instead of neutral. And this last thing, does anybody know what this is called? Come on, guys, this is very, very common. इसको कहते हैं lime water. Where is it used?
For the test of carbon dioxide.
Yes, it is used to test carbon dioxide. So testing carbon dioxide. It basically turns milky because it reacts and goes back to becoming quicklime when you add carbon dioxide to it. Calcium carbonate भी बन जाता है उससे. ठीक है? So you have to understand these things and you have to remember these things. Okay, based on the idea of what transition metals and their other ions are, can you tell me what color aluminium ion will have? Or aluminium hydroxide for that matter? What color will it have?
A white compound.
Very good. It will be white. Okay. So about aluminium, what do you need to remember? About aluminium, you need to remember that aluminium has a non-porous oxide layer that make it unreactive. You also have to remember that it has low density, and because of that is used in aircraft parts. And the third thing you have to remember is that this reduces nitrate ion. Okay, so nitrate ion can be reduced using aluminium, which is why whenever you have, अगर कभी भी टेस्ट आ जाता है नाइट्रेट आयन का, या कभी भी वो किसी टेस्ट में एल्यूमिनियम यूज कर लेता है, तो कंफर्म बात है कि वो नाइट्रेट आयन की बात कर रहा है. ठीक है. सिमिलरली बेरियम की अगर बात आती है, कभी भी बेरियम कॉम्पाउंड आता है, सो दैट इज यूज्ड टू टेस्ट सल्फेट. ओके, सो जब भी कभी बेरियम की एग्जांपल लेता है वो, तो उसका मतलब है वो सल्फेट की बात कर रहा है. सिमिलरली जब भी कभी सिल्वर आयन की बात करता है, तो दे यूज इट टू टेस्ट हैलाइड्स, क्लोराइड, ब्रोमाइड, आयोडाइड. सो ये याद रखें, कभी भी एग्जाम में अगर सिल्वर आयन आ गया तो दैट इज योर हिंट टू नो कि अब सल्फेट की बात नहीं हो रही, अब वो क्लोराइड, ब्रोमाइड, आयोडाइड में से ही किसी को टेस्ट कर रहा है. बेरियम की बात आ गई है तो मतलब सल्फेट की बात कर रहा है, क्योंकि बेरियम सल्फेट व्हाइट होगा, सिल्वर क्लोराइड का अपना कलर होगा, सिल्वर ब्रोमाइड का अपना कलर होगा. और कलर क्यों होगा? क्योंकि वो ट्रांजिशन मेटल है, वो भी उनको कलर देता है, और वो ग्रुप 7 है तो वो भी कलर्स उनके होते हैं, अपने कलर्स होते हैं. ठीक है. तो ये कुछ चीजें हैं बेसिक सी जो आपको याद होनी चाहिए. सिमिलरली कॉपर के बारे में, कॉपर 2 सल्फेट is something that you have to remember, that this is blue, but when it is solid compared to when it is aqueous, or when it is copper sulfate with 5H2O, with this 5H2O is basically water of crystallization. This is again solid, but this has water in it. This thing is white, this thing is blue. So this is a chemical test for water. So test for water. आपके पास anhydrous copper sulfate आता है. This is anhydrous. Okay, anhydrous means that it doesn't have water, and this one is hydrated because it has water of crystallization. So copper 2 sulfate, which is anhydrous, is white, and when you add water to it, it becomes blue, which is a test for water. So this is a test that we can use for water. Okay. Similarly, another one is cobalt chloride. So cobalt chloride paper, which is again solid, when it converts to hydrated form, you don't need to remember, but it has 7 water molecules in it. You don't need to remember this. So this is again solid, but the color is that this one is blue and this one is pink. Same thing, you get copper chloride, which is blue, it will turn to pink when you add water to it. Same goes for copper 2 sulfate. So these metallic compounds are used to test for water. Okay, so the chemical test for water, if they ever ask, this is what it is going to be. ठीक हो गया? Any questions on this? Similarly, copper sulfate का एक और use जो आपको आना चाहिए, ठीक है? Copper sulfate aqueous used to purify copper. So you get impure copper and you get pure copper by using this in a process which is electrolysis. Okay? So again, we will study that in detail, but that is a fact that you have to remember. अगर कभी भी वो आपसे कहता है कि give an example of a compound that is used to purify copper, this is what is going to be. All right. Now here's a question. How can transition metals help reduce the energy requirement of industries? So the thing is, when you use them in industry, we can use them as catalysts. And catalysts lower the activation energy, which means they lower the energy demand for any reaction. So if you use them in industry and you have industrial processes for which you use them as catalysts, they can reduce the energy demand, they can conserve energy by that, and obviously save a lot of cost. Okay, so that is one advantage of using catalysts if they ever ask. Another thing that you need to know about is that metals, how are they extracted? So you see, metals, we get them from ores. Now, when you get them from ores, they are not in a situation or in a position that we can use them directly. They're very reacted with something else. They have a lot of impurities and all that. So what do? What we do is we purify them. So we use the reactivity series. कैसे? The displacement principle. Displacement principle was a more reactive substance can displace a less reactive substance. इसका मतलब है कि मेरे पास reactivity series है ना, तो जो चीज ऊपर है उसको यूज करके मैं नीचे वाली चीज को निकाल सकता हूँ. तो अगर मेरे पास एक कंपाउंड है, मैं reactivity series यहाँ पे लिख रहा हूँ. So let's suppose मेरे पास एक कंपाउंड है. So let's suppose this is what I have, and I have copper. Then I can use hydrogen to just get copper out. The reason is hydrogen is more reactive. So hydrogen is an important element which we use to extract different things. Similarly, carbon is another important element that we use to extract different metals. What we do is that मुझे पता है कि hydrogen is more reactive than copper. So if I have copper compound, let's suppose copper oxide है, और मैं उसको hydrogen से react करवाता हूँ, तो I will basically replace copper with hydrogen. So copper को displace कर देगी वो, and I will be able to get it. And what is the color of copper metal? It is pink. Okay, so copper solid will be extracted out of this solid, which is black in color. So copper oxide is black, but when I pass hydrogen over it, I'm able to get pink. And the reason is that hydrogen more reactive, right? Similarly, I can use carbon. Let's suppose मेरे पास iron oxide है. Again, this is rusted form of iron. और मुझे पता है कि कार्बन इज मोर रिएक्टिव देन दैट, तो मैं कार्बन से उसे रिएक्ट करवाऊंगा और मुझे कार्बन डाइऑक्साइड एंड आयरन मेटल मिल जाएगा. एंड हाउ एम आई एबल टू गेट दैट? दिस इज ग्रे इन कलर, बट हाउ एम आई एबल टू गेट दैट? दिस इज रेड इन कलर, एंड द रीजन इज रेड इज बिकॉज इट हैज आयरन 3 in it. But the reason this happens is because carbon is more reactive. Same reason. Displacement principle. So displacement principle is at the heart of any purification process. So again, you will obviously have to balance this equation. So you'll have what? Yeah, we will learn about balancing equation later on. Now, we can technically use magnesium to extract aluminium or calcium to extract magnesium, but that process is quite expensive because you will first extract calcium और फिर उसको जाया कर दोगे magnesium को निकालने के लिए. तो इसलिए what we do instead is that we use electrolysis. So इन सब के लिए हम electrolysis करते हैं. और इन सब के लिए हम redox करते हैं, because redox, in fact electrolysis is also redox, ठीक है, बट हम इनको इस तरह से करते हैं कि हम कार्बन और हाइड्रोजन के साथ करते हैं, क्योंकि कार्बन कैन प्योरीफाई देम because carbon is more reactive, and similarly hydrogen can purify that because hydrogen is more reactive. ठीक है, एक तो ये हो गया. अब इसी को हम फिर impure भी करते हैं. ये purification कर रहे थे ना, फिर हम उसको impure करते हैं क्योंकि pure metal किसी काम का नहीं होता. लेकिन फिर बात ये कि आप क्यों फिर उसको साफ कर रहे थे? साफ इसलिए कर रहे थे because we want to control what impurity goes into it and how much of that goes, which is why we then use alloys. Alloys are impure metals, but we control how much of impurity goes and what impurity goes. So usme steel hai, which is alloy of carbon, iron. You add iron with carbon, a very small amount of carbon, and then you can also add chromium, you can all add zinc, you can add many different metals depending on what properties you want. It makes them hard, it makes them lighter, it makes it cheaper, it makes them resistant to corrosion. So many advantages of alloys. It makes them beautiful. Okay? Similarly, we have brass, which we use in furniture and door knobs and whatnot. Okay? So these are two that you need to know about. Okay? अब होता क्या है, alloys क्यों यूज करते हैं? They are mixtures of metal plus something else. Okay, and why do we use them? Advantages of alloys, you need to know what they are. So it makes them beautiful, it makes them lighter, it makes it cheaper, it makes them resistant to corrosion. Okay, so all of those advantages of having alloys, and they also make it harder. Okay, and how do they do that? For that you have to understand what the structure of a metal is. So a typical metal, so here's how it goes. So a typical metal will have these layers. Whenever you are asked to draw it in the exam, you have to draw at least 3 layers. Okay, now these layers can easily slide. मैं एक को push करूंगा, वो उठ के side पे चली जाएगी. But an alloy doesn't do that. What an alloy does is that it has these mismatched different sizes of particles. So now it's harder to slide. Of course, we still have free electrons. Of course, this still conducts electricity, but this is going to be much harder to. So this is hard, this is soft, and that is the reason we use alloys all the time. ठीक है? और अब आखिरी बात ये आ जाती है, and this is where I'm going to end. Recycling metals. So first of all, why is there a need to recycle metals? The reason is that metals are finite. Getting metals out, purification process, extraction process, that is very difficult, time consuming, very expensive sometimes. So using that finite resource, we can use, it has many economic advantages. Obviously सस्ता पड़ेगा अगर आप recycle करते हो, और आपको recycle करने का मतलब ये है that you're not throwing it out, which means you don't have to have landfills, you don't pollute the environment as much, you are not damaging the ocean as much. Okay, and you can get that precious metal out and you can simply sell it for scrap, simplify it, purify it, all of that दोबारा use हो जाता है. Another advantage is political. There are places where they have metallic mines of metals, but those places, because of those mines, these mines have become a curse for them. For example, right now, the longest running conflict in the world, which is Congo War. Congo War was basically a part of it. There's a war going on in the middle of Africa, Central Africa actually. And one major reason why that war is still raging on is the requirement of metals from there. So there are mines in there that have metals that we use to make these phones or laptops and all those things. And because of such a huge demand for those, the war has simply been going on. People want to control those mines. If, let's suppose, instead of throwing your old laptop away or instead of throwing your old phone away, we start to recycle them, and 7 billion people start to recycle them, then it is possible that we won't need to produce more of them, or demand कम कर देंगे, जिसकी वजह से those people will have less of an motive to continue with the war and all that. And wars have these long-lasting effect on people, on environment, on countries, on regions. So social फायदे हैं, economic फायदे हैं, environmental फायदे हैं. नुकसान सिर्फ एक है. Recycling is expensive sometimes, and recycling is difficult. क्योंकि आपको मेटल मिला है, आपने उस मेटल को प्योरीफाई करना है, सॉर्ट आउट करना है. आपको क्या पता है ये आयरन की कौन सी परसेंटेज वाला स्टील है? तो उसके लिए right now we need a very good breakthrough into this technology, And I'm hopeful students of tomorrow will be able to do it. Okay, students of today will as well, but they will be able to find methods to recycle them and find a method that works, that is cheaper, that is more convenient to do. क्योंकि आजकल recycling में सबसे बड़ा issue ये है that it is not as convenient as we would like it to be, which is why people get discouraged. Okay, so that's metals, that's periodic table. We have studied all of it, and I'm glad that you were able to do it. One last definition: radioactive substances. Many metals, they are radioactive. Many isotopes they have is radioactive, and radioactive materials are simply that are continuously breaking down to give off energy, and they glow sometimes. So they are damaging to human health. Obviously, they break the tissue and they break the cell wall or cell membrane in the cells. People who study bio would know it better. Yeah, so that's radioactive materials.